a condition given to us that the sum of a, b and c is pi radian. We need to show that cosine squared a added to cosine squared b plus cosine squared c equals 1 minus 2 times the product of cosine of a, cosine of b and cosine of c. Okay, let us begin. So we'll start our proof from the left hand side. On the left side we have cosine squared a added to cosine squared b plus cosine squared c. Now, in order to solve this problem, what we'll do, we're going to transform cosine squared b to sine. So how shall we do that? That's a very simple task. We know that sine squared b added to cosine squared b, that's always going to be 1. So this is a standard trig identity. So cosine squared b can be expressed in terms of the sine function as 1 minus sine squared b. Okay, so we will get cosine squared a added to 1 minus sine squared b plus cosine squared c. Now, as you can see there, once we transform cosine squared b to 1 minus sine squared b, that takes care of the term 1, which is also present on the right hand side. Okay, so let's keep let's make 1 as the first term. Now we have 1 added to cosine squared a minus sine squared b added to cosine squared c. Okay, now what we will do, we're going to apply a formula here, because cosine squared a minus sine squared b, there's a standard formula. So cosine squared a minus sine squared b, this can be expanded to get cosine of a plus b multiplied to cosine of a minus b. So we will now get 1 added to cosine of the angle a plus b multiplied to cosine of the angle a minus b added to cosine squared c. Okay, now what we'll do, we're going to use the condition that a plus b plus c equals to pi to change cosine of a plus b. Now let's use this. Since it's given in the problem that a plus b plus c equals to pi radian, so a plus b can be also expressed as pi minus c. Now we take the cosine function on both sides to get cosine of a plus b, that's going to be equals to cosine of pi minus c. Now what is cosine of pi minus c? That's given by negative cosine of c. Now pi minus c indicates that we are in the second quadrant, and in the second quadrant the cosine function is negative. That's why we have the negative sign. In other words, what we have done here, we have shown that if a plus b plus c equals to pi radians, then it is true that cosine of a plus b, that's going to be equals to negative cosine c. So we're going to replace cosine of a plus b with negative cosine c. That's going to give us 1 minus cosine of the angle c multiplied to cosine of the angle a minus b added to cosine squared c. Okay, so now we have 3 terms. So we'll keep 1 as it is, and from the second term and the third term we're going to take negative cosine c as the common factor, because we need a cosine c here. So once we take negative cosine c as the common factor, so this gets multiplied to cosine of the angle a minus b minus, and from the third term we are left with cosine c. Okay, now what we'll do, we're going to combine the 2 terms within the parentheses, cosine of a minus b and cosine of c. But before doing that, we're also going to change the angle c of cosine c to a and b. How shall we do that? Again, we use this fact that since a plus b equals to pi, so we use the fact that c equals to pi minus a plus b. Now what we'll do, we're going to take the cosine function on both sides. The cosine of c, that's going to be equals to cosine of the angle pi minus a plus b. Okay, now what is cosine of pi minus some angle theta? That's going to be equals to negative cosine of the angle a plus b. Now we can rewrite the expression within the parentheses as the cosine of c gets multiplied to cosine of the angle a minus b. So we have negative cosine c, that is going to become positive cosine of the angle a plus b. Okay, fine. Now what we'll do here is we are going to add the 2 cosine function by using the standard formula. That means if we have cosine of angle C added to cosine of angle D. This is given by the 2 times the product of cosine of C plus D over 2 multiplied to cosine of the angle C minus D over 2. Okay, so let's do one thing. For simplicity, let's consider A plus B to be C and A minus B to be equals to D. Okay, so now what we will get is 1 minus cosine of angle C multiplied to, so cosine of D added to cosine of C, so we'll get the factor 2 multiplied to cosine of the angle. So we need C plus D. So A plus B added to A minus B, that gives us 2A divided by 2 multiplied to cosine of the angle. Now we need C minus D. So C minus D, that's going to give us 2 times B divided by 2. So we get 1 minus 2 times cosine of angle C times cosine of angle A times cosine of angle B. And that is exactly the expression on the right hand side. So let's verify it. So we needed 1 minus 2 times the product of cosine A, cosine B and cosine C. So here we have successfully showed that thus the left hand side equals to the right hand side. Hence proved.